So once we establish the radius of convergence here, so the radius is going to be it's going to have a radius of 3 and it's going to have endpoints at 1 and 7. We need to test those endpoints. So we're going to test the endpoint x equals 1, and when we plug it in, we're going to end up with this series. So we're going to end up with 1 minus 4, so that's going to be negative 3 to the power n. So it's going to look like this. We can have negative 1 to the n plus 1 over n to the power 3n, and this becomes negative 3 to the n. Okay, so if we factor out that negative, we can get rid of that power 3 term. Okay, so it's going to look like this. N equals 0. Just going to zoom in a little bit here. N equals 0 to infinity. Okay, and we're going to end up with negative 1 to the n plus 1 times negative 1 to the n to power 3n over n to the power 3n. Okay, so a few things will cancel out here. So we can cancel out those 3 to the power n's. This is going to be, so what's happening here? This will end up being 2n plus 1, which means that this is always going to be odd. The power is always going to be odd, which means we're always going to end up with negative 1. Or another way you can think of it is when this is odd, this is even. When this is odd, this is even. Okay, so we're always going to end up with an odd power. So when we simplify that, that's going to be always negative. Okay, so n equals 0 to infinity. It's going to be negative 1 over n. Well, this is a harmonic series. It's not alternating, so we know this is divergent. Okay, this is divergent. So if we go back to our interval here, I know that we do not include the endpoints. I'm just going to keep track of it like that. Okay, so I go back. I need to then test the other endpoint. Okay, so when I test the other endpoint when n is equal to, or when x is equal to 7, so we need to test x equals 7. My series now looks like this. From n equals 0 to infinity, negative 1 to the n plus 1. It's going to be, when I plug in the 7 into here, it becomes 7 minus 4, which is 3 to the power n. Well, that's going to cancel with that 3 to the power n. So I end up with 3 to the power n over n. This is going to be 3 to the power n. Okay, so what's going to happen to those terms? Well, those will cancel out. So we end up with, in this case, this is going to be alternating. So that's going to make this alternate between negative 1 and positive 1. So we're going to end up with an alternating harmonic series. Well, from what we know, alternating harmonic series are convergent. So this is an alternating convergence. So I'm going to just state this convergent because alternating geometric series, or sorry, alternating harmonic series. Now again, we could do some formal tests with this, but really we shouldn't have to, because these are fairly standard converging and diverging series. So we should be able to make these we don't really need to prove these. Okay, although we do have tests to prove them as well. So I'm just going to keep track of my endpoint here. So there it is. So now to finish off this, I'm just going to state my interval of convergence. So my interval of convergence. Okay, my interval of convergence is going to be from 1 to 7. It's a half open interval, so it includes 7, doesn't include 1.